Greetings everyone, my name is Loke. I'm a PhD in civil engineering student at the Cape Peninsula University of Technology, located in Cape Town, South Africa. I am very honored to be presenting to you a paper entitled Characterization of Historic Mortars for Compatible Restoration, Case Study of South Africa. This paper was compiled by myself, Dr. Kumar, Pallav, and Professor Haldenwang. The outline of my presentation will include the background. I'll take us through the background of the South African historic buildings, the motivation, what motivated us to conduct this study, the methodology we used, and the results we obtained, as well as discussing those results. I'll conclude by outlining the future work on this topic. The history of South African construction industry dates as far back as the Castle of Good Hope, the Slave Lodge, the Robben Island, the Union Buildings, the memorials and cathedrals, among many others. These structures represent the political slavery, liberation, the religious history of South Africa, and its development throughout the years, while also contributing towards economic growth through tourism. These structures portray marvelous architectural designs and were built using unique materials. The study focused on two historical buildings in Cape Town, being the first one, the Castle of Good Hope, which is the oldest colonial building constructed in 1666, and the buildings on Robben Island, which was used as a political prison, known for detaining the South African first Black president, Dr. Nelson Mandela, and it dates as far back as the 1700s. The motivation. The selection of restoration mortars for heritage buildings is a challenge that can lead to loss of authenticity for these structures. Due to aging and other environmental factors such as change in weather, rainfall, heritage masonries tend to decay over time, and this threatens their existence. Therefore, in attempts to restore these structures, Portland cement is often used, and this approach is said to fail, as the Portland cement has different properties to the lime that was originally used. This practice has become common not only in South Africa but abroad. The common challenges facing historic restoration are, for example, the mortar decay, loss of authenticity, the lack of maintenance, and need for repeated repairs due to failure on existing repairs. The regular maintenance with incompatible materials, for example, Portland cement in most cases. Now, the current gap in the literature is finding the compatible repair mortars for heritage buildings, not only in South Africa but abroad. This can be achieved through material characterization, which is a new concept altogether for South Africa. Therefore, the buildings on the island have undergone maintenance and repair works in recent years, which in the island's assessment report, it was stated that the repairs on the wall pointing did not consider how air circulates through the wall sections and how condensation and dampness were to be treated. It has been concluded that the repair work caused further damages to wall sections. Therefore, the South African Heritage Resources Agency has proposed maintenance work to rectify the previous restoration mistakes on the island itself. As we can see, this does not only affect the authenticity of the island, but it also costs the country a lot of money. Figure 3 shows some of the deterioration on the maximum prison wall, which is one of the buildings on Robben Island. As we can see, The repair ordinary Portland cement material is detaching from the original lime material. And on the other side is the castle's masonry on figure 4, whereby the original surface is totally different from the repaired surface. Therefore, there's disparity on the entire wall section. In order to address this problem, this study proposed and conducted an experimental approach which characterized the original mortars from the two buildings, the two structures. Therefore, this was supported by quite a significant amount of literature which supports the characterization of original materials prior to restoration works. Therefore, before conducting this study, the South African National Heritage Resources Act requires one to acquire a permit, which was granted by the South African Heritage Resources Agency for us to collect the hardened mortar samples from the old kitchen wall at the castle and the maximum prison and pre-primary school building on Robben Island. The following experiments were conducted. The first was just a visual investigation whereby site visits were done and the walls on the two structures were assessed. The cohesion test was conducted, followed by a microscopic and titration, as well as the precipitation test. As we can see on the first image, the sample was placed under a microscope, and the image shown on the laptop showing the particle distribution on the mortar. After conducting the microscopic analysis, the material was gently crushed using a mortar and a pestle in order to separate the binder, the material believed to be a binder, which is the material below the 0.063 millimeter sieve, and then the material above that sieve, which is considered the aggregate. Thereafter, titration test using a method by Middendorf 2005 was conducted. These are some of the results on the mortars from the Castle of Good Hope. As we can see, the samples, the 9 samples that were collected were whitish in color. They were tough when breaking, and they had cementation indices ranging between 0.3 and 2. Therefore, the binder used in these materials was subhydraulic lime mostly, and the 3 samples, which is sample 7, 8, and 9, were made of F. So they were F mortars. As it can be seen on figure 5, precipitation of salts in the mortar was done on the mortar filtrates after digesting the mortar into acid. Therefore, the results indicated that most of the samples from the castle were rich in chlorides and carbonates and very poor in nitrates. Generally, the aesthetic and physical results indicated whitish lime mortars with seashell fragments having diameters between 0.5 and 25 millimeters, and the clear repair mortars detaching from the original surface, which were believed to be Portland cement. It was also evident from the masonry that the applied repair materials did not match well with the original materials, and this was concluded based on the time frame of the repairs and the condition of the recent repaired areas. In conclusion, we can conclude that material characterization is a topic of concern for sustainable restoration of heritage structures. However, this topic is yet to be explored in detail across Africa. Thus, restoration of historic masonries is carried out using the materials that do not match the original. The current and the future proposed work as the research on mechanical characterization of heritage mortars for the two structures, the production of compatible restoration mortars, and it will be very beneficial to focus on a study addressing general material analysis other than mortars that would yield a detailed recommendation on the repair of heritage buildings that will better suit the original materials. As it is evident on the surfaces of Castle and the Robben Island buildings, Portland cement fails in the restoration of historic line mortars. Therefore, further investigation into the alternative repair materials that will match the original is underway. Finally, I wish to sincerely pass my gratitude to the government of Lesotho and the Cape Peninsula University of Technology for financial support on this study, the South African Heritage Resources Agency for granting me a permit to conduct a study on two of the most precious monuments in the country, the castle and the island management and the staff for granting me access to their sites and their cooperation. Last but not least, my sincere gratitude goes to the laboratory assistants, Ms. Lanjwa and Ms. Matobela. Without their laboratory support, this study wouldn't have been a success. I thank you.